Hi, and welcome to our video on percent of change today. What is percent of change? Well, according to the definition here, it indicates how much a quantity increases or decreases, that means goes up or down, with respect to the original amount. The original amount is what we started with. So this formula right here that I'm going to star is important. You will be using it throughout this lesson. The quantity of increase or decrease, that is how much it went up or down by, is equal to the percent times the whole, and that whole is going to be our original or our starting amount. So let's start with our first example. These are all going to have to do with increases at the beginning here. In example 1, Cassandra likes jewelry. She has 5 rings in her jewelry box. Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? So let's go back to that formula. We rewrote it here for you. The quantity of increase, how much did her collection go up by? How many rings did she add to it? If you come up into the problem here, it says that she got another ring. That's one more ring. So the quantity of increase is 1 is equal to the percent, and that's what we're looking for, times the whole, and the whole is her starting amount. How many did she start with? Well, if you come up into the problem here, I've highlighted it, she started with 5 rings. So our whole, or our original amount, is 5. So we have that as an equation. 1 is equal to, we're going to call the percent P because we don't know it, times 5. We're going to solve this equation, and to do that, we're going to divide both sides by 5. So then my percent, it's going to come out in decimal form. Do 1 divided by 5 on your calculator. These 5's cancel out, and it comes out to 0.2. That's in decimal form. We need to change it to a percent, multiply it by 100, which means move that decimal over 2 spots. We'll need to put in a 0 there, and it comes out to 20% increase. I'd like you to go ahead and hit pause, try this next problem about John, and then come back when you're done. All right, let's see how you did here. The quantity of increase, how much did his collection go up by? Well, up in the question it said it went up by 5 cards. So that's 5 is equal to the percent, we'll call P, times the whole. What did he start with? He started with 15 cards. So if we go ahead and solve for P, we divide both sides by 15. These cancel out. 5 divided by 15, P is going to equal 0.3 repeating. So when we go ahead and change that into a percent, we multiply by 100. Remember, these 3's repeat, so this is going to equal 33.3 repeating percent, and that is an increase. All right, let's go ahead and look at example 2 here. In 1970, the price of gas was $1.70. In 2010, the price of gas was $2.95. Find the percent of change in the cost of gasoline from 1970 to 2010 and round your answer to the nearest tenth. The difference in this problem is they don't tell us specifically how much it went up by. We have to figure that out. So look at the 2 numbers that we have. In 1970 was our starting number, 170, and in 2010 is our ending number of $2.95. In order to figure out how much it went up by, we will have to subtract these 2 numbers. So $2 and, sorry about that, wrote that wrong, $2.95 minus the $1.70. That will equal my percent times my whole, which is my starting amount, and that was $1.70. Go ahead and do this subtraction first. $2.95 minus $1.70. You do that on your calculator, it comes out to $1.25, and that's equal to P times $1.70. We're going to divide both sides by $1.70. Those will cancel. P equals, if you go ahead and do that on your calculator, that division there, it comes out to about 0.7352. And we need to change this into a percent, multiply by 100. So we have 73 And this 5 right here, is it going to stay a 5 or go up to a 6? Well, the 2 tells us that it will stay a 5. So 73.5% increase. All right. Next example here, example 3, it's the same process, just you don't have all the words that go with it. It tells you the starting amount, the original, and it tells you what it ended up at, the new amount. So we still need to subtract to figure out what the difference is. So $143 minus 55 is equal to my percent that I don't know times the whole, my starting amount or the original of 55. Do your subtraction first. 143 minus 55 is 88. And that equals my percent times 55. We're going to divide by 55, divide by 55. Those will cancel out. What is 88 divided by 55? If you put that in on your calculator, it comes out to 1.6. Change that into a percent. Move the decimal over twice. You'll need a 0 there. It comes out to 160% increase. And that seems big, but if you increase something by 100%, that means you double it, like you increase it by its whole amount. So if we increase by 160%, we're more than doubling something. Did we more than double here? Well, doubling 55 would be 110. Yeah, we did more than double. So this answer does make sense. All right, we go to the next page here. I'd like you to try this next problem. Hit pause and we'll see how you do. All right, let's take a look at how you did here. We have to find the quantity of increase. That means we're going to subtract the numbers. 25 minus 20, and that's going to equal my percent times my whole, which is my original, of 20. Do the subtraction here, and you get 5 is equal to P times 20. Divide by 20, divide by 20, and 5 divided by 20 is 0.25. Change that into a percent, multiply by 100, and it comes out to a 25% increase. How'd you do on that one? Good job. All right, now we're going to be doing pretty much the same thing, except our numbers are going to be going down instead of up. It's a percent decrease. So in example 4, Ken said he's going to reduce the number of calories that he eats during the day. He reduced the amount of calories he consumed from 2,500 to 2,200 calories per day. What percent did Ken reduce his calorie intake? So we're going to need to figure out how much did it go down by. So we go up to the problem and we see he started at 2,500 and he ended at 2,200. Subtract those. And that's equal to my percent times my whole, which is the starting amount. Where did he start at? He started at 2,500. So do the subtraction first. 2,500 minus 2,200 is 300. That is equal to my percent times 2,500. Divide by 2,500. Cancel, cancel. 300 divided by 2,500. If you do that on your calculator, we get that P is equal to 0.12. We need to change that into a percent, multiply by 100, and that comes out to 12% decrease. All right, if you would go ahead and hit pause, try this next problem. Okay, welcome back. Same process here. We're going to take our two numbers and subtract them to get the quantity of decrease. So we're going to do 349 minus 273, and that's going to equal the percent times the whole, which was my starting number of 349. If we do this subtraction, we end up with 76 equals P times 349. Divide both sides by 349, and those cancel, and we get P is equal to, comes out to about, when you do that division there, 0.217, And we want to round to the nearest whole percent. So if I move that decimal over twice, multiplying by 100, we get 21.7, but the nearest whole percent, would that be 21 or 22? It would be 22% decrease. Hopefully we check out more books next month. In example 5, moving on here, we have the same type of thing that we had on the percent of increase, where we're going to have to subtract our original and our new. So 20 minus 15 will equal my percent P times my whole, which was my original, the starting number. 20 minus 15 is 5. That equals P times 20. Divide by 20 on each side. Those cancel, and P is equal to 5 divided by 20 is equal to 0.25. Multiply it by 100 so that we change it into a percent, and that comes out to 25% decrease. Go ahead and hit pause and try this next problem, please. All right, let's check and see how you did. We're going to need to do 75 minus 35. That's equal to my percent times my whole, or my original amount of 75. Do the subtraction first, and that ends up being 40. Divide both sides by 75. And we get P is equal to 40 divided by 75 comes out to 0.53, where the 3 repeats. So when we multiply this by 100, we end up with 53 point, remember that 3 is going on forever, so we have a 3 repeating here, percent decrease. All right, how you doing so far? Great. We're going to change gears a little bit here, and we're going to now be given the percent, and you're going to have to find the starting amount. So let's look at example 6 here. The population of cats in a rural neighborhood has declined in the past year by roughly 30%. Residents hypothesize that this is due to wild coyotes preying on the cats. The current cat population in the neighborhood is estimated to be 12. Approximately how many cats were originally in the neighborhood? So we want to look, do we know the part or the whole? The number that we know is 12. Is that the number of cats that we started with, or the number of cats that we ended up with? It's the number of cats that we ended up with, so that is the part that we ended up with, not the whole that we started with. So we know the part, which is how many cats were left. Is this a percent increase or decrease? Well, this highlighted word right here tells us declined is a percent decrease. So go ahead and write that down, percent decrease. Because, it says, how do you know? Because the word declined means to go down. All right, in this next question here, if there were about 30% decline in the cat population, what percent of the cats remain? Well, if we started with 100% of the cats and they went down, or we subtracted 30% of them out, would we still have? We still have 70% of them. So if we go back to the equation that we worked with yesterday, how do we write? The equation is part equals percent times whole. What is the part of the cats that are still left? That is 12. That's equal to my percent. Now the percent remaining, so that is the 100% and taking away the 30%, times my whole, which is my starting amount, and I don't know that number, so we'll call it W. Okay, let's solve this equation. 12 is equal to, let's actually subtract that and call it 70% times W. Divide by 70%, divide by 70%. Those cancel. Go ahead on your calculator, do 12 divided by 70%, and we find that W is equal to 17.1. Can we have 17.1 cats? No, we can't. We need to call that W is equal to 17 cats originally in the neighborhood. There we go. All right, we have one more example to do, so go ahead and turn the page. In example 7, it's going to be very similar to what we just did, but instead of a decrease, it's going to be an increase. Jessica's math level on her achievement test in 7th grade was a level 650. Her math teacher told her that her test level went up by 25% from her 6th grade test score level. What was her test score level in 6th grade? So is this a percent of increase or decrease? Well, right here, this word up tells me that it is an increase. So we'll say percent increase because it says it went up. Okay, and if her 6th grade test score level represents the whole, what percent represents the 7th grade level? Well, if the 6th grade level was 100% of her score and she went up by 25%, that means we're adding 25% to her score, and it's actually 125%. So if we go ahead and use the equation, part equals percent times whole, the part is her 7th grade score, which was 650, and that's equal to her 6th grade score percent, which is 100%, plus the 25% increase, times the whole amount, and that's her 6th grade score, and we don't know it. So let's go ahead and add 650 is equal to 125% times the whole, or the original amount, divide by 125%. If you go ahead and do that on your calculator, 650 divided by 125%, oops, sorry, I put a wrong variable there. W, our whole, or the original amount, is equal to 520. So 520 was Jessica's 6th grade score, or level, I guess. And that makes sense that her level was lower in 6th grade than it was in 7th grade. 520 is lower than 650. She did go up. That does make sense. That's all we have for today, so thanks, and we'll see you later.